Hello, this is Rich. In this tutorial, I'm actually going to teach you how to use the SnAPI.Reflection module. This is more of a feature overview slash demonstration, technical demonstration versus a tutorial, but let's get started. Now, the SnAPI.Reflection module provides full-blown C++ reflection. Pretty amazing. Probably the best feature about it is that it's non-intrusive and completely library-based. Now, what does this mean? It means that there's no code generation phase at all, and there's no pre-processing phase. It's completely done with the library. That's it. That's all you need. Now, the non-destructive part means that it can work with any third-party library or any API in C++, right out the box. You don't need to modify any of those classes. You can do it if you just have a header file, or you can have reflections to these classes and stuff. If you just have a header file, or have a DLL, or anything like that. If you can get the memory address of a method, you can add reflection to it. So it's completely non-intrusive. So here we go. Let's get started. Now what we're going to do is I'm going to show you a couple methods as a demonstration to reflect the standard library's string class. Okay, and I chose a string class because it's actually a template class. I want to show you I handle templates as well, because an std string is actually just a templatized version, specialization of a basic string. Okay, so I'm going to show you that it works here. So here's what we're going to have to do. We're going to grab the reflection module, and we're going to grab the reflection system. Now everything that has to do with reflection goes right through the reflection system, and we're going to lock it. Now don't mind these lock calls. I use shared pointers and weak pointers for the entire memory management of all SnAPI modules, so there's no leaking. So what we're going to do is we're going to lock to get that shared pointer. I'm going to completely get rid of all error checking here just for the sake of brevity. So lock just returns a shared pointer or null if it doesn't exist. So we got the reflection system. Now what we're going to do is get a class. Now what we can do is we can type in the name of the class we want. We can get an alias. Okay, so we can get an alias, or we can type in the actual class's name. And so we can type in something like string, which is an alias for the string class. So when you register a class for reflection, you can optionally add an alias instead of the actual name. But if you wanted to actually use a class's name, then you could simply use the StringUtils static class here and do class to string, passing in the string class. So we'll do that. Okay, so we want to get the string class here. So it's going to turn the class's name into an actual string. This won't turn it into, it won't return a string called exactly std : string. It's going to return like the actual type in a string format. So std basic underscore string, a locator, all that stuff. That's what it's actually going to return as a string. So what we're going to do here is we're going to say auto, and we're going to do string class. So we got this class, we're going to lock it up. So we got the shared pointer here. So now we have the string class. And what are we going to do? We got to create an instance of it. So I'm going to show you two methods on how to invoke methods on an instance. A dynamic way and a static way of doing it. The dynamic way is a little bit slow. Actually, it's quite a bit slower, but still good speed. But the regular invoke, the non-dynamic invoke, is blazing fast. We'll get into performance in another video, but the performance is actually, let me put it this way, it's about 245 times faster than C#'s reflection system for the invoke, and that's not even counting the dynamic invoke. If we compare the invoke to C#'s dynamic invoke, it's something like 1,000 times faster. So it's 245 times faster around than C#'s invoke. So that just gives you a little bit of performance, but we'll get into that in another video. So we have the string class, and what do we want to do? We're going to construct it. Now, if you're familiar with the standard library string class, it has a constructor that accepts in a constant character, which is basically a string. So we're going to do that. Now, construct takes in an array, so we're going to use initializer because we can have as many parameters to the constructor as we want, because we don't know. Constructors can have as many as we want. We happen to know this is 1, and we're going to create a SnAPI, which is basically a container. The SnAPI class is part of the common module and allows it to hold any value and still provide type safety. So we're going to wrap it into SnAPI and say hello. There we go. So we're going to construct a string class. There we go. String inst. And this returns a class instance class. Okay, so now we have a dynamic class instance, and there we go. So we got to get these methods that we want to invoke. So we take the string class, and we just say get method. And what method do we want? Well, we're going to be using 2 methods for this example. The operator, the indexer, and the pushback. Because I want to show you that we can retrieve one of these letters here using the indexer, and we can also push back a letter to the end of the string, and then also retrieve that letter that we had just pushed back to show you that we actually pushed back. So we're going to get the operator indexer method, and we're going to lock it. Beautiful. So auto method indexer. Then we're going to do the exact same thing, but we're going to get the method push back. And we want the push back. Okay, beautiful. So now, very simply, let's invoke it. Let's take the method indexer, and since this is an instance method, okay, by the way, we can just check if it's instance by checking if it's static. So we can say, hey, method, are you static? Are you const? Let's take a look at the other things we got. Dynamic invoke, and the dynamic invoke variants of the calls basically allows you to call a method not knowing anything about the type at all, which is very, very useful. However, it is slower because it has to deduce the type internally. We can get the argument count, how many arguments this method has. We can actually get the argument type by passing in an index. So if your method takes in 3 arguments and you want to get the reflectable type of the second one, you'd pass in an index of 1, and it would return the class. It would return the class of the argument index. So you could actually, so if I had a method that has 3 parameters, an int, float, and a double, I can say, hey, what is the type of the first one? Well, it's an int. So I can actually get the int class and do some reflections on an int. So it's pretty badass that I could do that. Arg type names. What this will do is it'll get the actual string name of the type. So if it's a pointer, you'll get the type that it's a pointer type and all that kind of cool stuff. So the actual name. Get arg types. This gets all of the arguments types in an array. So you're getting all the arguments types. Get method pointer. You can get the actual underlying memory address of the method. So you can invoke the method if you wanted to on your own. You get the name of the function. The method. We can get the return type again. So if it returns a my class, and my class has a whole bunch of methods, I can get that type and also reflect the my class. I can instantiate it and all that stuff. So again, full-blown reflection. Invoke variants. It's super blazing fast because it uses. You'll have to know the type beforehand before you call it, and the type is deduced by the template. So you just put whatever in there, and it will deduce it. So there we go. That's what we got so far. So let's go ahead and we'll do the dynamic invoke first, okay? Just to show you how that works. So we're going to say dynamic invoke args because this returns a value, and we do need arguments to pass into it. So what do we need? This is a instance method, so we need an instance. So let's go ahead and pass that string inst in there. And again, this takes as many parameters as you want. It's dynamic. So we have to construct an array of C, and we'll do 1 argument there, so a SnAPI. And this is the indexer. So what does it take? It takes a size t variable, which is an index. So we want index 0. because we're going to see if we can retrieve this h here. Okay, so we're calling the indexer with an index of 0, one argument, not 0. Beautiful. And we're going to cast the return value into what? A car reference, because that's what the indexer returns. Indexer for a string returns a car reference. Okay? So auto letter. There we go. Now, one thing I want to point out is that the SnAPI class is what's returned from this dynamic invoke. The dynamic invoke versions return SnAPI, and they take in SnAPIs. This is because it needs to be dynamic. It needs to not worry about the type. You're not supposed to know what the type is. But internally, there is runtime checking going on in the dynamic versions. Meaning, if you do pass in an incompatible argument type, or you pass in the wrong number of arguments, or any of that kind of call the method mistakenly, you will get a runtime exception telling you why it was an error. So you get that full safety during runtime, so you don't have to worry about memory corruption and all that stuff, which is good. Like if I try to call this as method and I convert it to a car reference and it actually didn't return a car reference, boom, you'd get a runtime exception there telling you what's the deal. So here we go. Now that we got the letter, it should be H. Let's call the method pushback. Let's push back something. And we're going to do a dynamic invoke args because we do want to pass in what to push back. So we'll do string inst, right? And then we have an array of as many arguments as we want, but actually we only have one, so it's only add one element to this array. And we're going to do a size t. No, not a size t. We're going to push back a car, and we'll say exclamation point. So hello exclamation point is what we're going to push back there. Then let's do another call so that we can check to see if we actually pushed it back. So what index do we need? Well, we need 0, 1, 2, 3, 4, 5. We would need the 5th index after we push this back to get this car. So we'll say we want to call that indexer with an index of 5 there. So letter should be exclamation point here and H here. So let's go ahead and see if that is actually the case. Let's go ahead and debug this. All right, now there may be some errors here from typos, but let's take a look. Okay, beautiful. We were able to find the class appropriately. Let's go ahead and construct an instance, and we were able to construct an instance. Let's just go deep into the layer here so we can do some debugging, okay? And what do we see? All the way down here, we do have an actual string. So size, capacity, locator with the actual help. So after all this debugging all the way down here, you do see the underlying string in the instance here. So we have a method indexer. Let's go ahead and retrieve it. Beautiful. How about method pushback? Yep. Now letter. Let's go ahead and see. Oh, an H. Beautiful, because we got the 0th index, and that's the H. Let's go ahead and push back a character. Beautiful. And let's go ahead. See, this is an H now, but let's see what happens if I try to retrieve the 5th, which doesn't exist beforehand, but it will exist after we've pushed this back. And we do. We have an exclamation point. Can you see that? Beautiful. So that's exactly what we've done. We've completely reflected the string class in the standard library using the SnAPI.Reflection module. So I'm going to show you another way, a regular invoke. Okay, a regular invoke. And that will accept an actual instance here. So let's get rid of these invoke calls. And what we'll do is we'll say invoke, did this invoke return? Because we do return a value, but we can accept in 0 or more parameters. So since this is a regular invoke, we don't need to pad it with all this SnAPI stuff here. You can literally just pass in the type, and we actually know all the type there. So we can just do that. Now, this accepts an actual instance here. Now what we can do, because this is the invoke and not dynamic invoke, it actually wants a string instance. We can do two things. We can just do a string, right, and create a str instance there. And we can say str, and we can call it like that. We could. However, what we should do is we should retrieve the actual instance from the string instance. So here's what we're going to do. We're going to take the string inst, and we're going to get a reference to the underlying value, which is actually a SnAPI. So we're going to do an as, and we're going to convert it to a SnAPI. And then we're going to take that SnAPI, and we're going to convert that to the actual string instance. And since we use shared pointers, it's actually a shared pointer of std string. So never just try to get an std string, which is what you constructed. Always get a shared pointer version, because that's what is actually stored under there. And then we'll just dereference it. And the value, return value, is a car reference. So there we go. So we have a method indexer. We're going to invoke it. We're going to tell it the return type, pass in an actual instance of the string class that we're working on with the index of what we want here. Same thing here. So method pushback. We're going to call invoke, because we're not doing any sort of return value there. But we will take the string class, boom, boom, and pass in this car as a second parameter. Beautiful. Same thing here, method indexer. Actually, we can just take this call here and go over. Beautiful. So method indexer, invoke return. It returns a car reference. We're passing in the instance we want to work on, and we want the fifth. Okay. So let's go ahead and do that. So I'm showing you the dynamic version and then the non-dynamic version. Got it. Got it. Let's see what letter. H. Nice. We'll push it back. And H. And it's a exclamation point. So there you have it. We have the two different variants of invoke. One's dynamic, which doesn't have to know anything about the type. It's just all done internally. And then there's the non-dynamic variants, which you can pass in the raw types because you know it beforehand, and it's a lot faster that way. So I hope you guys enjoyed. I hope you see the power in this, and hope you appreciate the effort I've put in. The SnAPI.Reflection module will be available to purchase soon. It's almost done. This still needs a little bit of work to go, but it's practically done. One thing I did not show in this video, which will be in another video, is you can reflect enums. So I reflect, interfaces, structs, classes, you name it, also enums, and I'll show you how we can do that in the next one. Okay. Thank you for watching the video. I hope you enjoyed. Leave a comment. Let me know what you think is awesome, what you think is not so awesome, and some suggestions to improve this. Thank you. Bye.